Yes.
So this is a presentation. This presentation is actually situated at the confluence, let me say, or at the interface between two rich and vibrant communities which concentrate on data and knowledge modeling, and both of those are core concerns of our group's collective research. So those two domains are knowledge representation, KR in short, and knowledge organization, KO in short, and this presentation is titled From Knowledge Representation to Knowledge Organization and Back. So in the course of the presentation, I will give a brief overview of knowledge representation and knowledge organization, and then I will try to establish that what is the synergy between KR and KO, why are we talking about this, and what are their, complementary strengths and weaknesses between these two domains. And out of these synergy, strength, and weaknesses, I will uh, propose or advance two research questions, and subsequently in the other two sections that you see from KR to KO and back, these two will actually answer those two research questions that I will propose. And these two actually from KR to KO, I will go through the high level aspects of KR methodology and KO methodology, and then I will show how KO can improve KR. And then I will very briefly go through some of the implications which uh, which are evident in some of the past experiments and studies what we have done, and the key takeaways, and then some of the ongoing and future work. So knowledge representation, I assume most of us know, it is a very core area of artificial intelligence, and it deals with how knowledge can be represented within intelligent systems. And here knowledge can be at different levels of abstraction. KR might be concerned with common sense knowledge, it might be concerned, mostly it is nowadays concerned with domain knowledge. So we talk of domain ontologies. Then it might also be concentrated on application ontologies, or even uh, knowledge. We can also interpret knowledge as instantiated knowledge, which is like data points which are attached to ontologies. So therefore, and not only, this type of different levels of representation, I say that I stated, KR also deals with reasoning, the consistency of the knowledge that are represented, and also how such knowledge potentially might be reused in some other, let's say, in some other use case scenario or application scenario. So to that effect, knowledge representation has a wide orbit, let's say, has a wide ambit, and it covers several different types of knowledge representation artifacts. So there are conceptual models which are like these diagrams that we see, ER diagrams, which are mostly informal, and also UML diagrams, which are, can say, a bit advanced version of ER, but still they are informal in the sense they don't have any semantics, ontological semantics embedded in them. But then there are ontologies, which we know, like are shared conceptualizations for a particular domain, which are reusable. And then now, for some years now, we speak of knowledge graphs, which are like ontologies potentially populated with millions of data points. So these are some of the, let's say, mainstream KR artifacts which are there. And then the use of these KR artifacts, how they are generated, and if they are generated, how they should be used. These are the concerns of KR methodologies, which are also there are available several significant methodologies. One of the earliest being Ontology Development 101, which essentially showed how to practically build an ontology step by step. Then there were several intermediate methodologies, and there was another significant methodology, which is methontology, which said that ontology building is not necessarily a step by, not necessarily limited to a step by step approach of building, practically building an ontology, but it also factored in reuse. And it showed that ontology building is essentially cyclic, that you start from a point and again you come back to that point. And this is where the reuse occurs. And then also DERA, which is, I can say, our group's contribution uh, to KR methodologies, where they conceptualize the domain as being composed of entity relationships and attributes, and how these three ERA can be composed to form, domain descriptive ontologies. And then these type of KR artifacts and KR methodologies are find several applications. Some of the conventional applications are data annotation. A great example of data annotation can be found in gene ontology and the studies. There are several published papers, especially on gene ontology, which show how powerful it is for annotating biomarkers and other biomedical data. But then there is data integration. Again, on this topic, our group has done a lot of work, especially in healthcare, over different projects. And but then the applications can also be a bit unconventional, which I say here as innovative, like image annotation. For example, a prominent example in this is ImageNet, where the WordNet ontology is being used to structure, thousands and thousands of images into a hierarchy. So they say that, okay, for example, let's say something like this, a dog node in that coordinate ontology would be populated with lots of images. Then dogs can have many specialized dogs, right? So there again, those subsequent children nodes will again be populated with hundreds and hundreds of images. Each node around 500, 600 images. Each node is populated with around 500, 600 images. So, the point is that even ontologies find application in this kind of innovative areas. So, uh, to support these artifacts, methodologies, and this type of diverse applications, KR has developed and has become highly mature in terms of supporting technology. And here I must mention the semantic web technology stack. Essentially is composed of these standards that we heavily use in our group also, RDF, RDFS, OWL, etc. And then this KR has also become highly scalable in terms of services, technology-based services. Like for example, these conceptual models, ontologies, they can be exposed. They can be hosted in a repository and exposed via data catalogs, right? What we are also doing with, for example, live knowledge and previously live schema. And these data catalogs can also have several advanced inbuilt services like live schema, for example, at these basic services like download, search, filter, based on the metadata. But then again, it also has more specialized, let's say, more advanced services like two, three different kinds of visualizations of a schema, of an ontological schema. Then it can be exported in form of FCA format, like format concept analysis format, which can be easily used for performing experiments on knowledge embedding, for instance. So all of these are, very advanced in KR in terms of artifacts, methodologies, applications, as well as technology. But even then, a criticism has been throughout that KR has traditionally underemphasized modeling quality. So that means there are lots of papers, let me say, which point out that these hierarchies, which point out essentially semantic errors in conceptual models, in ontologies, and even in knowledge graphs. There is a famous paper actually on the wiki knowledge graph, like uncovering conceptual disarrays in wiki knowledge graph. And then there are lots of papers, for instance, in ontology-driven conceptual models. So whenever some group, for example, develop an ontology-driven conceptual model, on the back, underlying that model, they they have a kind of a static ontology, let's say, which is based on their theories, ontological theories. So each group, different groups have different theories, and based on that, they have this underlying ontology based on which these models are developed. So almost all of these theories have uh, some logical rules which cannot be violated. Like, for example, there is a fixed A node and there is a fixed B node. And they say that B cannot be a child of A, something like that. And if this is violated, they call it as anti-patterns, which are essentially very bad for semantic quality of that conceptual model. So there have been a lot of studies in ontologies, in conceptual models, as well as in knowledge graphs, but these studies have been mostly, let me say, focused on pointing out the errors. These have not been focused on, okay, there are errors, but how in the methodology level by design itself we can try to minimize, or even if best, if totally solve these kind of errors. So these studies have been mostly focused on pointing out the errors and not incorporating some additional steps in the methodology to solve those errors. And this is not also, restricted to this knowledge level, so-called knowledge level that I'm talking. This has a significant effect at the data level also, and that's why there are a lot of systematically flawed data sets which have been designed according to QAR models. ImageNet again is a very big example. So they have inherited almost all of the semantic flaws that are there in the WordNet ontology. They have inherited, and subsequently the images which have been populated, which have been used in ImageNet to populate that WordNet ontology. Many of the images have been miscategorized, let me say, or misclassified in that ontology due to the error of the ontology itself, or maybe say due to the lack of guiding principles which enabled this misclassification. So this is some sort of a brief overview of knowledge representation. Now let me come to knowledge organization, which is a very important area of information science, which essentially deals with classification and description of information resources in memory institutions. Now, memory institutions can be of different types, right? There can be galleries, libraries, which are maybe the most prominent memory institution that we encounter often day-to-day life, but there are also archives and museums also. So if we talk of libraries, the information resources in libraries mainly are books, periodicals like journals, magazines, then might be monographs, some presentation, either hard copy or digital copies of some presentations, and maybe another two or three types of. So, I mean, to say that in a library there are not more than 7, 8 major types of information resources or entities, let's say. So, I mean, the area which deals with the classification and description of these type of bibliographic resources is what is KO, knowledge organization. And to do that, to facilitate the classification and description, KO has also developed a wide spectrum of artifacts, for example, classification schemes and catalogs codes. So classification scheme is essentially, again, for a particular subject. Let's say you have to classify, categorize, keep in the library shelves books of mathematics. So you have to have some kind of a hierarchy, right? In mathematics, there are lots of different subjects: linear algebra, abstract algebra, linear analysis, etc., etc. And within those, again, there are subtopics. And this is, again, expanding day by day with growing research in those areas. So you need a dynamic classification so that you can correlate that to the shelf when you place the hard copy book, or even if you do, for example, in a digital library, when you design the content taxonomy of a digital library, you need this kind of classification schemes for different subjects. And then catalog codes are there, which are essentially which specify how, what metadata properties should be used to describe a particular resource. For example, we have a book, and then let's more specify it. Let's say we have a mathematics book. So its classification will be done according to the classification scheme of mathematics, I mean that subject. But what are the metadata properties required for that book, like author, title, number of pages, publisher, etc., etc. These will be specified by a specification, which is the catalog code. And these are essentially, in knowledge organization, these are actually documents or standards, not very digitalized, let's say. And then to connect, to seamlessly connect this classification and catalog within a methodology to do this entire, from starting from a, for example, a book, to placing it in the library, proper place, proper shelf in the library. There have been several methodologies, like, for example, enumerative approach and facet-analytical approach. I will not go into details for this, but facet-analytical approach is the one which I will discuss. And of course, KO has conventional applications like organizing books in a library, but it has also innovative applications, like these principles are used for developing content taxonomies. A very prominent example is the Google product taxonomy, which Google uses. Uh, it uses this taxonomy to automatically classify the product it indexes. So this is one of the prominent example, or an innovative example of KO, I mean application of KO. So just to provide some illustrations, because we are more familiar with ontologies and KR, but in KO we are not familiar. So on the left you can see a snapshot of a classification scheme of the subject education. So you can see there is this hierarchy: pre-secondary, adult, university. Within that, again, there are some sub hierarchies are there: medium of instruction, mother tongue, etc., etc. And then on the right hand side, you can see the example of a catalog record. So again, this is a book I have taken from education, which is philosophy of education. So what are the metadata properties which are describing this book? So this philosophy of education book will be classified in its proper place according to the scheme on the left, but its metadata will be classified according to a certain catalog code which is not there. And the properties are, like you can see, McLennan James Edward W. is the author, and then it's the sixth edition. It's published in London by Prentice Hall in 2006. It has 1030 pages. So these are some of the attributes, right? Of course, written in a typical library way, not the way we usually write, but essentially, functionally, these are the same. So, as we saw, like KO is predominantly intellectual, or let's say manual in nature, and less technology driven. But even with this disadvantage, it has a very positive key advantage that it has a huge body of guiding principles for generating high quality classification hierarchies, concept hierarchies, high quality descriptions like this metadata attributes. Which attributes should I choose for describing a particular resource? Which attributes should I avoid or reject for describing a particular? So this type of guidance is provided in the form of guidance principles, and in this particular area, KO is very rich. And this results in generation of high quality classification hierarchies, metadata models, and datasets. So now we saw briefly what is KR. We also saw briefly what is KO, and now we see. So the synergy is that both these areas in a way are very related because both of them focus on knowledge and data modeling. Of course, KR on a bigger scale, it can model any entity or any entity type. KO is more narrower in scope. It focuses mainly, let's say, on the bibliographic universe. To that extent, it has a very limited set of entities and entity types. And then KR and KO, based on this synergy or the similarity that we establish, it has also some complementary strengths and weaknesses that we also saw. So the strength of KR is that it has high technology support and technology enabled services. It has weaknesses that it emphasizes very much less on modeling quality. KO, on the other hand, is very high because it has a huge body of guiding principles which are known as canons for generating high quality models, but it is the weakness is that it is less technology driven. So in this paper, we are concerning on this underlined point. So we are saying that we have this weakness in KR that it emphasizes less on modeling quality, and this is exactly the strength of KO. So how can we include the strength of KO, which focuses really on high quality models, and use it to improve the modeling quality of KR? And that leads to my two research questions. So the first question, we have to first establish that, we establish a broad synergy, but we also have to establish a high level phase by phase, let's say functional correspondence between the high level views of KR and KO methodologies. And here by functional correspondence, I mean a high level functional correspondence. So for example, an artifact in KR and an artifact in KO might be at the high level, they are functionally similar, but at the level of formats, at the level of how they are structured, they might be different. So we are concerning on that high level functional correspondence between these two methodologies, whether it is there, and for example, if there is this correspondence, whether these two can be like collapsed into one single integrated methodology, which has all the strengths of KR plus the modeling quality, that is the canons of KO. So this is my second research question. So first we essentially describe, we go from KR to KO. So we concentrate on a very high level view of a KR methodology, which is our KR methodology essentially, and a KO methodology, which is the one proposed by the Indian librarian information scientist Ranganathan. And we will focus of course I focused in the paper, but here as much as time permits, we'll focus on step-by-step phases, and within those phases, the roles, artifacts, and actions between these two methodologies. So let's first concentrate on KR. So as you can see on the right-hand side, this is the diagram. High-level view, of course, details are omitted. So as you can see, the Aristotle is, for example, is the genesis, right? They give the ideas of genus differentia, which is the guiding principles which language engineer uses, and then the methodology proceeds with these kind of roles. The person images are roles, right? And the labels, the edged, the labels on the edges, they denote actions, and the other emojis, I mean icons, are artifacts. So KR methodology has four high-level phases. First phase is lightweight ontology generation. Second is entity type graph repository generation. Third is entity graph generation, which is a kind of knowledge graph. And fourthly, how user uses this. So let me go one by one to make it more clear. So first you can see this bounded curve that I have done. This shows the okay, another thing I should mention that in this KR methodology, the purpose is always provided by the user. So the user decide what type of entity should be classified, interrelated, described. So in this lightweight ontology generation phase, I mean, guiding principles of genus differentia are followed, which was proposed by Aristotle almost 2 millennia ago. But essentially, fundamentally, that same principle is followed, and those principles are taken in input, adhered to, let's say, by the language engineer, and it generates this kind of wordnet-like lexical semantic hierarchies for different domains in different formats. They generate this, and these different hierarchies, wordnet-like hierarchies, are composed to design the lexical semantic resource. For example, the UKC that we have, right? So a lexical semantic resource, within that it will have all of these different language specific hierarchies in different natural languages, domain languages, but also like our UKC, it might also have this supralingual layer, right, which combines these different language specific hierarchies into a common concept core. And then based on these hierarchies that are there, these lexical semantic hierarchies that are there, the knowledge engineer uses these hierarchies to create the lightweight ontology. So lightweight ontology is essentially, I mean, for a particular purpose, for a particular use case, it is essentially the taxonomy or the taxonomy backbone which can classify the data sets, for example, which need to be integrated for a particular purpose. And for that, the knowledge engineer always respects as much as possible the hierarchy that is encoded in this kind of lexical semantic hierarchies in the lexical semantic resource. And also the knowledge engineer consults, let's say, the dataset schemas, because the dataset schemas also have the properties, right, which describe that entity in that particular dataset. And this gives an exact idea of how the inheritance hierarchy, I mean the hierarchy in the lightweight ontology, the taxonomic hierarchy, let's say, should be organized the exact way. So the knowledge engineer consults these two to form the lightweight ontology. Then in the second phase, it is the phase of the entity type graph repository, which has all these entity type graphs are essentially the ontological representations of entity types of which the entities are there in the datasets. So ontological representation means ETGs have these properties like data properties which describe a particular entity and object properties which interrelate type of entity. But here you can see in this particular KR methodology, there is totally a gap between the beginning. Let's say, I mean, nothing is there below Aristotle, right? And nothing connects from the starting of the methodology to this phase. I mean, no quality or guiding principles, nothing is there, randomly starts. So that means the ETG, even if there, it's not very much checked through the quality principles that should be conformed to while developing those ETGs. Then the third phase is that the data scientist, he or she takes an ETG as an appropriate. Of course, he or she takes the lightweight ontology, the taxonomy that was generated, takes the concrete data sets also, concrete data sets now, not the schemas, and then the ETG repository, and I mean from the ETG repository, an appropriate ETG. And this actually here there is some merging, right? ETG, since it is an ontological representation, it also describes more abstract concepts and also some concrete concepts as well. And also additionally, very importantly, it has these object and data properties. Whereas lightweight ontology is more like, since it is based on these dataset schemas, they describe more specific concepts. They don't have much description, much modeling about these abstract concepts. So the data scientist first merges this ETG, which has abstract concepts plus some specific plus these properties, with this lightweight ontology, which has more specific concepts. And then one by one, it maps one dataset at a time to that particular combined artifact of ETG and lightweight ontology. And this is done, of course, the details are in the ITLO's methodology that we have and that we teach in our course. They generate this entity graph, which is a kind of knowledge graph. And then finally, the user can use this knowledge graph diverse myriad types of ways, right? Which I don't go much details. Then I move on to the KO methodology, which is again, as you can see in the right hand side, similarly divided into 4 phases: classification, catalog code generation, catalog record generation, and reader services. So here you can see the first phase of knowledge organization methodology. Here, instead of Aristotle, the guiding principles are provided by Ranganathan, whose name I mentioned. He's provided all these theories of facet-analytical knowledge organization. So he has postulated these kind of canons or guiding principles, which a classificationist consults or adheres to these guiding principles and generates classification schedule, like the one of education that I showed you before, right? For each subject, since now we are talking of bibliographic universe, for each subject, they develop these different classification schedules, which are again like hierarchies of concepts, abstract finer concepts. And then the action moves to classifier. So in this case, the data or the data sets, there are no data sets as such, right? But there are books, actual books, physical copies of books. So the classifier consults the subject matter of the book. Here at this step, the classifier does not consult the actual details, like in which year the book was published, the number of pages, etc., etc. Rather, he or she consults the topic of the book, because he has to place that topic in that classification schedule, right? So he or she takes the classification schedule, he or she takes the topic or the thought content of that book and generates a book classification number. This is essentially a unique number describing the place of the topic of that book in a classification schedule. So this is the entire phase of classification. But then there is an additional phase, which is cataloging. So here essentially what we are there, I mean KO is trying to achieve is that it is trying to detail a specification of, for example, what type of metadata properties should be there for a book. How should it be different from the metadata properties, let's say, uh, for a journal or a periodical? How it should be different for, I don't know, like a map or something like that. So this catalog code generation. So catalog code is a kind of a documented specification which which based on some guidelines which provide that for this particular resource, these are some of the metadata properties which should be described. So again, here Ranganathan provides canons for cataloging. So these are guiding principles which ensure the quality of metadata properties. And based on these, the catalog code designer designs a specification that, okay, for books, these are the 15 set of metadata properties that should be there. For something else, periodical, these are some of them. So this type of documentary specification is generated, which is the catalog code. But notice here, differently from the KR methodology, here there is a complete connection from the start to this catalog code, right? And connection, not only just connection in terms of quality principles, but also connection in terms of a role, which helps to ensure that these quality principles are adhered to. Okay, and then, okay, just a brief overview, since canons are very important, right? Both for classification, the first loop, in the first segment and the second segment. Canons of classifications are used to guide the design of classification hierarchies in terms of what characteristics, what differential, let's say, should be chosen step by step to generate a classification hierarchy. How a particular path in the classification hierarchy should be modeled. There are canons which say that there should be no missing links, for instance, in a path in the classification hierarchy, and how levels, and levels here I mean within a classification hierarchy there is also these horizontal levels, right, which we call as depth 1 hierarchy, depth 2 hierarchy. So how concepts should be organized in these levels. So it is also very important because, for example, while modeling, many people make this mistake that they often make from a parent class, they make a single child, which is wrong actually. If there is a single child, that means you can keep the parent class itself. Only when you classify only when there are at least two children, which disjointly combines to form the parent class. And then there are canons for cataloging, which guide the design of how to generate those metadata properties, and in terms of terminology, in terms of relevance, in terms of currency here we mean we should use the terminology in the metadata property, we should use the terminology which is used today, in today's day, not for example which was used in 1850s. And then contextuality, like whether this set of metadata property should be used or not. And I don't detail each of them, but this is just an overview. And then coming back, I mean, we saw the classification, we saw the cataloging, and then now the cataloger takes in the physical copy of the book, the catalog code, which gives this reusable specification of metadata properties and the book classification number, and it generates the book catalog record, which I showed you one example, like philosophy of education, which had these different authors, dates, etc., etc. And then, of course, the last step is that the reader uses it. And here, especially, we should note that the purpose is fixed for this methodology. It is to classify and catalog library resources. There is no user providing any external purpose. So what is the, now we should concentrate where this back and back comes from. We are saying like KR to KO and back. So now we attempt a functional mapping between the KR and KO methodology that we saw, and this will provide a solution to question 1, research question 1. And then finally we see, based on that functional mapping, can we collapse these two methodologies into one methodology which has all these different strengths. This leads to research question 2. So here you can say briefly a functional mapping between KR and KO that you saw, and also the phases are also delineated as I described. So I will not go into detail, but let me say the first phase in both the methodologies do some kind of a classification They generate some kind of a classification hierarchy, and they also, based on the classification hierarchy, they also try to place either data or books uh, in particular. I mean, they see how that particular classification, based on that original classification schedule or lexical semantic hierarchy, how uh, for that particular use case, how that particular classification schedule hierarchy should be generated. So essentially, in general, we can say both these concentrate on classification. Into both of these at a very high level, they concentrate on properties, metadata properties, like data properties, object properties, right? Catalog code also does that. Entity type graph also does that. It does have a hierarchy, but the main point is that it endows the lightweight ontology with properties. But we can see, of course, in KO it's linked to the beginning, in KR it's missing. And then again, the phase 3 is again at a high level. These are functionally similar because the cataloger as well as the data scientists, they are taking in three inputs, merging together and forming book catalog record or entity graph, which are essentially functionally the same artifact at a high level. Of course, in terms of format and other stuff, they are different. And then, of course, user and reader, they are all exploiting this output. So that level also functionally, at a high level, these are similar. So it seems that due to these functional mappings, these can be collapsed into one single methodology. And for that, we will keep our base as KR because we are trying to improve the KR methodology, right? We are trying to create this link between ETG and from starting to ETG, and we superimpose this KO methodology to KR and see whether there can be a link achieved. So now, if we do that, and while maintaining the KR methodology, we see that there can be possibly a single integrated methodology is divided into again 4 phases. Number 1, 3, 4 phases are actually the same as KR, but the major difference is this portion because here you see it's totally connected. The ETG repository is connected with the beginning, the start of the methodology, and here Ranganathan, and we are doing currently ongoing work on Ranganathan how to modify and adapt his canons, guiding principles of classification and cataloging to generate better quality ETG models which compose to form the ETG repository. So first step I am actually not saying because it's already late and essentially the same as KR methodology. So in this step actually what we do is that we introduce, along with Aristotle, we introduce Ranganathan's guiding principles. You can see Ranganathan is providing guiding principles in terms of the canons of cataloging and classification, and the ontology engineer actually there is a new role which is not there before and which is also not same as the catalog code engineer, but that detailed description is not possible now. I mean, it takes the ontology engineer takes these guiding principles and designs high quality entity type graphs which are stored in this ETG repository, or at least expected to, because these extensive set of principles definitely give better results, as has been proved in research papers also, numerous research papers. And then essentially the methodology is same. The data scientist takes these three inputs to generate the entity graph and the user uses it. So yeah, this is again a comparison because here, as you can see, right on the left top left hand side, there is this KR methodology which has data scientist, which is doing two tasks essentially. First, it is selecting, I mean choosing, because here the ETG is not quality controlled, right? So the data scientist has to put extra effort to choose which type of data properties should be there in my ultimately in my knowledge graph. So that 1.2, that is what I indicate by 1.2. But it additionally is also doing the merge of these three inputs to generate the entity graph. So I put 1.2 plus 2.2. In the KO, this step is not exactly similar. So here in KO, because there is already a catalog code designer who is ensuring based on principles that, he is already specifying what metadata property should be there, right? So this responsibility, that combined responsibility of data science, right, is split here. So the catalog code designer is focusing on this metadata properties, the data attributes. The cataloger is just merging these three inputs together. Whereas in the KO-enriched KR, the data scientist here also is similar to the cataloger, is just merging. But this ontology engineer is doing two things. It is doing similar to the catalog code designer. It is based on the properties. It is ensuring that correct metadata properties and data attributes are there in the ETGs within that ETG repository, but it is also ensuring based on the canons of classification that the hierarchy of ETG is also semantically sound. So it is doing two things, and this 2.3 is indeed a new role which you cannot see in the earlier two methodologies. So what are the implications? The main implication in terms of data science, let's say, of this KO-enriched KR methodology is that it includes knowledge quality, quality of knowledge models and data quality. And there is a big issue in computer vision, which is known as fine-grained image annotation, right? For example, let's say there are 200 categories of dogs. So how to create a classification category, semantically sound classification hierarchy of that 200 dogs, and then annotate, populate each of these node with 500, 600 or 200, 300 images. This is very difficult, right? But Ranganathan's methodology is innately suitable for this kind of depth classification. So depth classification hierarchies has been generated in library science now from 50, 60 years. So it is innately suitable to generate this kind of depth classification hierarchies which can significantly improve fine-grained image annotation. And we have also done one experiment, right, which has an adapted form of this KO-enriched KR methodology in ImageNet, musical instruments, hierarchy, and there is this link which I have given of this paper. It was accepted at ICAI, and it led to substantial improvement in model accuracy between 10 to 25%, if I am not wrong. Varies between the models, but the CV models which were trained on this improvised hierarchy. And then it also improved the inter-annotator agreement, who were annotating those images based on this redesigned hierarchy, and this inter-annotator agreement was calculated based on Krippendorf's alpha, and it achieved near perfect agreement in case of experts and substantial agreements in case of non-experts. So the key takeaways are that we saw a high-level phase-by-phase view of standard knowledge representation methodology and standard facet-analytical knowledge organization methodology. We saw that there can be at a very high level a functional synergy or a functional sync between KO and KR at different levels of abstraction, like the goal itself, the synergy of the goal between KR and KO is same. The phases are same, and then even, which I did not detail too much, at the component, actions, roles, etc. level also functionally they are same, but then there are differences as you saw in the methodology, right? KR is not connected. From the beginning to ETG there is total blank, whereas the others are connected, and then some of the roles are not really completely aligned. So we saw the synergy, but we saw also some differences, and the outcome was a proposal of an integrated KO-enriched KR methodology, which has been validated due to this ImageNet study that we did. Ongoing work is that we saw like we have done in this work, we have taken the weakness of KR, which is underlined, and the strength of KO, and we saw how the strength of KO can be plugged into KR. Now the next step is that how the strength of KR can be plugged into KO. The strength of KR is technology and technology-enabled services. How, I mean, KO, which is technologically weak, let's say, how it can be, KR can improve KO, so that we can have a complete loop where KO improves KR and KR improves KO. So this is the ongoing and the future work, and that's it.
Thank you so much, Mayuk. Anyone with a question? Do you have any questions? Can you hear me?
Yes, I could hear you.
Oh, okay. If anyone has a question, please put up your hand. Oh, okay. So it seems like there's no question. Maybe just to clarify, Mayuk. So at first, as you were presenting, I thought that literally the methodology is applied on only books or things in the library. So it's the end that showed. So maybe you correct me. Is it that you can apply the methodology to other items in limited? No, and it's not limited to only the library or books.
Talking of, I mean, the KO, the KR, or the integrated.
The integrated, because
Integrated,
the
you
integrated is what you're making, right?
yeah. So integrated you can apply to any kinds of entities because it is essentially a KR methodology, but enriched via the principles of KO. So you can use it in for any types of entities, not just books limited.
Okay, thank you so much. Any other question? Oh, okay. So since there is no question, we shall end here. Thank you so much, Mayur.
Thank you. Bye.
Okay, bye.